Hi guys, welcome back. Now, in this session, we're going to discuss something called as the factorial. So this factorial is a very interesting program because we can use both the recursion and iteration to solve this problem. And factorial is mainly used in the probability and permutations and combinations and all this, right? So let us see what is a factorial and how can we mathematically define a factorial. So the symbol that we use to denote factorial is this exclamation mark. So this is what is called a factorial symbol. Okay, so what is a factorial of, let us say, a value n? So what is n factorial is equals to? So this can be defined as the value n multiplied by its preceding value n minus 1, which in turn is multiplied by n minus 2, and this product will happen till we reach 1, 2 and 1. So this is what we can call as the factorial function, right? So this is a factorial. So to take an example, let us take 4 factorial. So what would be the value of 4 factorial? It would be 4 into 3 into 2 into 1, which is equal to 24. And there are many interesting properties for factorials, and I don't think we need them for our lesson preparation. So let us see how can we write an algorithm that can implement this factorial function. So how can we use iteration? So is there anything that you can see that we can that lets us understand that iteration can be used? So it looks like whenever we are multiplying something, we're actually decrementing the value, and we are doing that till we get n, or in a very counter in in a very counterintuitive way, you can say that I'm starting with 1 and I'm multiplying with a value which is just next to that till I reach n. So there is two ways of actually solving it. So how can we write an algorithm? Let's say we have some value, like say p is equals to 1, and then you're going to run a loop from I is probably say 1 till n, and what are you going to do? You're going to say product is equals to product times the value I, let's say the variable is I, so product times I, and we're going to increment I with a factor of 1. So this should be the basic code that can be used for iteration. So let's code it up in Python. So let's take an integer, so as we now have the integer, let us initialize a variable product. This is initially 1. So 1. Wait, why is this happening? Okay, so now let us iterate for I in range. Okay, I'm going to start from 1. I cannot start from a 0 because the entire product will be 0. So starting from 1, I will go till n. So if we were to go till n, then we have to mention that we need to go till n plus 1 so that it will move exactly till n. So what are we doing? So we are making the product is equals to product, so product times the I. Okay, so now let's print the product. So do we have any issues? I gotta find out. So for 4, the answer is 24. Yeah, this looks fine. We can format this a little bit and say we don't need a product. Maybe we can optimize this in a way that we can just use the end, right? You can say I'm going to iterate from from n I'm going to go till 1 with a negative step. Then I don't need this production. I can just say my n will be equals to n times the I, and this will still print factorial. I think. Let us run this. Let us say 496. Okay, I think have we messed up? N is equals to n into I. Okay, it's not actually n into I because we need a variable. Just take m, which is 1. So it's m is equals to m into I. So we have to initialize it with 1. We cannot use the variable n. Now let's look at the recursive approach. In this recursive approach, what are we going to do? So let's say we are calling a function f which will take the value 4. So how can you define the factorial of 4? It would be 4 multiplied by its next one, that is 4 minus 3. And similarly, f of 3 is nothing but 3, the value n multiplied by n minus 2, that is 2. And 2 is nothing but 2 multiplied by f of 1. So f of 1 is nothing but it's going to return 1. So this whole thing is going to return 2. So this whole thing is going to return 6. And so it's going to return 6. This whole thing is going to return 24. So this is another way we can get to factorial, and this actually is a more intuitive way of doing that. So let's define this function f. Then it will take n. So let us write the general condition first, that is we'll say n multiplied by let's say return n multiplied by function times n minus 1, but this is the base case. So when are we gonna stop? If I get the n value is equal to 1, then I'm going to return 1, else I'm going to call this. So this is my function. Now let us define variable. Let's take n is equals to int of input and I'm going to call f with the value n, and I'm going to print that. Okay, now let's run this and see what do we get. Well, 4, I get 24. So it's very intuitive, right? So this is all about the factorial function, and we can also use something like dynamic programming to use that, but still I think this one is enough to crack your interviews, right? So okay, then we'll meet up with another problem.